Good morning, and thank you for joining us for our webinar with Schneider Electric this morning, brought to you by AEE Solar. Before we begin, if you're experiencing any technical difficulties, please notify me by typing your question into the questions section on the right-hand side of your screen and hitting send. I'm going to monitor for a second to make sure we don't have any technical issues. Looks like we should be good there. We will have a Q&A session following the presentation. You're welcome to submit questions at any point throughout the webinar, and we'll do our best to answer as many of the questions as possible if time allows during or if not afterwards. There will also be a brief survey that will pop up in a new window immediately following the webinar. Please, if you wouldn't mind taking a couple minutes to complete it, and we will then email you a copy of the presentation. If there are no questions, and I'm taking a look, looks like we're good so far. I'd like to introduce our presenter today, Schneider Electric's very own sales application engineer, Eric Bentsen. So hi, good morning, Eric. How are you?
Oh, I'm great, Erin. Thank you so much for giving me the opportunity to share with everyone today. And I know everybody's busy, and it means a lot to take time out of your busy schedule. So I'm excited and ready to get started.
Awesome. So, all right, well, take it away. I'm gonna turn the camera off here and get down to business.
Oh, thank you, Erin.
Of course,
All right.
thank you.
And thanks everybody for joining, and special thanks to Sunrun for putting this event together. My name is Eric Bentsen. I'm a sales application engineer with Schneider Electric. I've been with the company since the Xantrex days. Xantrex was bought by Schneider Electric in 2008. So I've seen a lot of changes in the industry, and I know a lot about our current platform and the predecessors of the existing platform. And so I'm ready to answer any of your questions. Today we are going to cover three-phase configuration with XW Pro. Our agenda, we're going to start with a little bit about Schneider Electric Solar. We'll take a look at our family of accessories. We'll look at the superior design of XW Pro, the technical specifications, configurations, balance of systems, 120 volt conversion, and some example systems. So let's go ahead and get started. And again, thanks for joining. So Schneider Electric is a growing technology company providing energy, automation, and digital solutions for our customers around the world, while continuing our strong commitment to innovation. 29% of our business is right here in North America. It's worth mentioning that Schneider Electric was voted the most sustainable corporation by the Global 100 Index. With over 20 years of experience, Schneider Electric Solar provides a mature residential and small commercial solar with storage solution with unmatched reliability and versatility. Our digital offers include a powerful solar monitoring platform that is easy to use with remote access from anywhere with an internet connection, including advanced data security. We're committed toward a future of energy independence for our customers. Some other companies under the Schneider Electric umbrella are easily recognized names in the industry, such as Square D, APC, and ASCO. In the United States, residential and commercial buildings account for 40% of the energy consumption, according to the United States Energy Information Administration. Electrical distribution systems are the third leading cause of home structure fires. Each year in the United States, arcing faults are responsible for starting more than 28,000 home fires, killing and injuring hundreds of people, and causing over $700 million in property damage. With energy costs increasing Efficiency plays a crucial role in savings. Avoiding peak rates with storage is an effective strategy to reduce electric bills. Now people are returning to their places of employment in many cases where commercial buildings may benefit from having solar with storage. Schneider Electric Solar offers a complete suite of products that are proven to offer unparalleled reliability and versatility for residential and small commercial applications. Our XW Pro platform is the latest in smart grid technology and offers UL 1741 SA compliance with advanced grid interactive functionality. XW Pro can be AC coupled with third-party PV inverters or DC coupled. We offer a range of solar charge controllers for DC coupling, including MPPT 60, a passively cooled 60 amp model with a max PV input voltage of 150 volts DC. We offer two models of high voltage solar charge controllers, which include the MPPT 80 and MPPT 100, each of which has a 600 volt DC limit for PV voltage and offer 80 and 100 amps of charge current, respectively. We have taken monitoring to a whole new level with Inside Home and Inside Facility, which offer local area network connectivity with data push to Inside Cloud for remote monitoring and control. Our mobile app provides real-time power flow, performance history, and events. Alerts are available via push notifications and email. Our full-size power distribution panel provides balance of systems for multi-unit XW Pro systems up to 3 units, where the mini PDP offers a more cost-effective balance of system solution for single inverters. Connect's config tool allows the exceptional installer to calibrate AC voltage and save configuration files for quick and easy configuration of cookie cutter systems. Disconnect RS offers arc fault rapid shutdown compliance for rooftop solar when used with our solar charge controllers. Finally, the automatic generator start offers automatic starting and stopping of a generator with voltage or state of charge triggers available. It should be noted that XW Pro and AGS work very well with generators. In fact, the system is smart enough to shut down the generator when the grid returns. This is because XW Pro has a separate input for grid and a secondary input for a generator. You can even change the AC association in case you want to integrate 2 generators. We should also mention we have the Connect battery monitor for open loop systems that will give you a coulomb counter that tracks the current in and out of the battery for accurate state of charge to take advantage of the state of charge control features within the XW Pro. We also have closed loop communication with many popular batteries on the market, including Discover, Fortress, Blue Planet. So if you have any questions on those, we'd be happy to answer those offline. XW Pro is an extension of the legacy XW and XW Plus models that have proven reliability in the field since 2006. Thousands of systems are still in operation with no end in sight. Part of the reason is due to the isolated compartment for airflow, which is unique to the XW platform. Dust can accumulate on circuit boards over time and inhibit cooling of components. Some dust may even have conductive properties that may lead to premature failure. XW Pro ships with a foam filter that mounts on the bottom just below the fan intake. In very dusty environments, such as wood shops, it is recommended to clean the filter regularly. XW Pro boasts an 80-pound toroidal transformer that gives it such a robust surge capability, which is 12 kW for 60 seconds at 25 C. Toroidal transformers are more compact, more efficient, and offer less noise than a standard EI transformer. Note the fan sitting just below the transformer. XW Pro monitors heat sink temperature and transformer temperature. In environments with higher ambient temperatures, use the derating chart in the manual to calculate your maximum continuous power in the warmest part of the year. unless of course the system is located in a controlled environment. XW Pro has a pure sine wave output, better under load than most generators, with a total harmonic distortion of less than 5% at full load. The heatsink protrudes through the separation barrier with a rubber seal that keeps air flowing across the heatsink isolated. The robust and technologically advanced design of the power bridge has remained unchanged through the years. Here you can see the remainder of the PC boards are populated, with the AC board on the left. A completely redesigned control board is in the upper right, and the network board is in the lower right corner. We will focus in on the AC board a bit later, as this component must be modified for three-phase configuration. Here's the tail of the tape. Be careful when comparing to competitors' technical specifications, as some express peak power, that is 1.4 times higher than RMS power, which does the actual work. Note the specifications for 120 volt, which are relevant for three-phase configurations with XW Pro. The limitation for continuous output is due to the 60 amp breaker size when applying the 80% rule. NEC defines continuous power as 3 hours or more, so it is possible to obtain full power for periods of less than 3 hours. For a three-phase system, XW Pro requires 1 or 2 inverters per phase. A 3-inverter system supplies a nominal 20 kW, while a 6-inverter system provides 40 kW. Be aware that 2 XW Pro units cannot recognize 2 lines of a 3-phase source. The 3-phase XW Pro system will have a common neutral. From line to line, you have 208 volts. From each line to neutral, you have 120 volts. Here's a 40 kW system represented. A 6-inverter system will require 2 power distribution panels. More on how everything ties together later in this presentation. Now let's have a look at modes of operation. First, let's start out with AC coupling, where a 3-phase PV inverter is located at the backup load panel. This visual shows grid voltage passing through the XW Pro, battery full, and allowing PV to add power to the AC bus. Any excess power will flow toward the main panel. Any remaining power will flow back to the grid. XW Pro is also capable of charging the batteries when needed. You can program to charge only during solar hours by using the charge block function, which prevents charging during a specified block of time, for example, to avoid peak rates. In a backup scenario or a power outage, XW Pro forms the grid voltage and frequency, allowing the PV inverter to produce power. If the loads require more power than the PV can supply, the remainder will come from the battery. If the PV power exceeds the load demand, the excess will charge the battery until full, after which time the frequency shift algorithm will curtail PV production to protect the battery from being overcharged. Here's an AC coupled system that is grid connected with a backup generator. The interlocked relay prevents the generator from being backfed with excess PV power. Some advantages of AC coupling are better efficiency when PV is supplying the loads in real time, and it's easier to retrofit existing PV systems. Now let's have a look at a DC coupled configuration. Advantages to DC coupling are better efficiency when storing energy for use at a later time, and being able to monitor PV through our Insight platform. When an AC pass-through and grid power is present, the inverter charger will pass that power through directly to the AC appliances, and the PV power will charge the battery. When in grid support mode, the PV is used to support the load, typically after the battery is fully charged. When in cell mode, any excess PV will be exported back toward the main panel. Any remaining power will flow back to the grid. Load shave will prioritize stored energy over what is drawn from the grid. Load shave has a start time and a stop time associated with it. Now let's focus on how everything physically connects together. Note the system has zero clearance mounting capability with the power distribution panel to the far right. All knockouts are symmetrical for mounting the power distribution panel on the left or even in the middle if preferred. The power distribution panel without AC breakers is part number 865-1014-01. It is typically the part number that you would use for the three-phase system. It supplies a 250 amp DC breaker for a single XW Pro, for DC cables and Arctic UltraFlax number 6 AWG wiring for the AC side, and also a conduit box. You may use PDP part number 865-1015-01 if you're unable to locate the 1014 model through your distributor. You'll just need to set aside the 3 QOU 260 breakers and use them for a different job. Those are the single phase 2-pole breakers. A connection kit will be needed for each additional XW Pro. So the PDP gives you the balance of systems for the first one, and then for phase B and C, you'll need an additional connection kit for each one. That's part number 865-1020-02. This includes a 250 amp DC breaker, conduit box, DC cables, and AC wires. The three-phase breaker kit, which is part number 865-1315-01, supplies 3 Square D QOU 360 3-pole 60 amp breakers, a set of power distribution jumpers for the AC bypass breaker, and a sliding interlock plate that prevents bypass and load breakers from being energized simultaneously. This protects the inverter from backfeed. Here you can see how these breakers are wired with respect to the grid input and the load output. The connections to the three-phase XW Pro system are also identified. Note that a generator breaker is not shown or supplied. Each phase has dual aluminum lugs that can accept up to 2/0 AWG cables. Each XW Pro ships configured for 120/240 split phase by default. For a three-phase system, each XW Pro must be converted to 120 volts. This is accomplished by installing the jumpers. There's 3 large and 1 small jumper that are supplied in the bag of hardware that ships with each XW Pro. which also includes brass DC terminal fasteners, a 5-pin Phoenix connector for the aux port, a battery temperature sensor, a foam air filter, DC terminal covers, and a network terminator for Xanbus. Please don't throw the bag away because that hardware is not sold separately. First step in 120-volt conversion is moving the transformer wires and installing the small jumper. Note the AC board is displayed with the location of the transformer wires identified. On the right, you can see the before and after photos of the transformer wires and their respective positions, and the location of the small U-shaped jumper. This removes the center tap lead and allows the full transformer winding to be utilized for a single 120-volt connection. Next, the large jumpers are used to short L2 to neutral on grid and generator input terminals and also the load terminal. Note the AC wiring terminal block identified in the photo. Also note the photo to the right showing the bottom fed AC wiring terminals populated with load, grid, and generator wires, along with the position of the large U-shaped jumpers. All neutrals on the AC board are common. As such, only one neutral connection is necessary on each XW Pro. From a hardware perspective, we now have a 120-volt inverter charger. Next, the 120-volt firmware will finalize the conversion process. Now that all three XW Pros have had the transformer wires moved and the jumpers installed, connect Xanbus and Sync cables. These are just simple Ethernet cables. Then energize one XW Pro at a time with battery voltage. Each XW Pro will have a dedicated 250 amp DC breaker in the PDP. The three-phase system should have a common battery bank. The Xanbus network should be terminated, meaning no open Xanbus ports. Sync ports do not require termination. Each XW Pro has 2 Xanbus ports and 2 sync ports that allow daisy chaining of these devices together. Next, add Inside Home or Inside Facility to the Xanbus network. These devices are powered by XW Pro, so make sure the battery breaker is turned on for at least one inverter. Inside Home should be okay for a 3-phase system that is AC coupled. For a DC coupled system with more than 3 MPPT controllers, consider using Inside Facility, which has 2 Xanbus networks. Next, save XW Pro 120-volt firmware onto your laptop, which is available on the website. Simply enter sesolar.com into your web browser, navigate to the XW Pro download section, and click the Firmware tab. It'll be a good idea to download the latest firmware for Inside Home or Inside Facility just in case. They will use the same firmware file. In fact, the only major difference between Inside Home and Inside Facility is that Inside Home has a single Xanbus network, while Inside Facility has 2 Xanbus networks. Inside Home and Inside Facility broadcast a Wi-Fi signal that allow a direct connection to your laptop without a router. This is probably the easiest way to get connected for the first time. Search for Inside Home or Inside Facility in your list of available Wi-Fi signals on your laptop. Then enter the Wi-Fi password located on a sticker on the back of Inside Home or Inside Facility. Then enter the default IP of 192.168.100.1 into your web browser. Then you can log into Inside Local, which is the web page. The default username is admin and the password is admin123. If Inside Home or Inside Facility doesn't have the latest firmware, as indicated on the top left of the web page, click Status, Firmware Upgrade, and browse for the e-package file that you saved to your computer from the website. Upgrading Inside Home or Inside Facility firmware takes about 5 minutes. Then you'll be required to restart the gateway, by clicking on a pop-up. Once the device is restarted and you've logged back in, click on the Devices tab. XW Pro will be listed as a device. Click on the XW Pro icon. Note that all devices can be placed into standby with a click of a button on the upper right side of the web page. Next, click the Firmware tab for the XW Pro. Be aware each XW Pro has a dedicated firmware tab. Browse to the location where you saved the 120-volt firmware file to your computer by clicking Upgrade. Once you select the file, the upgrade process will proceed. The total time to update XW Pro with 120-volt firmware is about 10 minutes. After the firmware upgrade is complete, click Setup, Region Settings. Enter the region settings passcode, which is indicated on the screen, and click OK. Then select and apply the appropriate region code for your utility. Off-grid can select IEEE 1547. Now turn off the DC breaker for the first XW Pro and energize the second XW Pro battery breaker. Repeat 120-volt firmware upgrade and region code selection for each unit. Once the third XW Pro is finished, it's time to program phase assignments. Each XW Pro has a dedicated configuration menu. Navigate to Advanced Multi-Unit Config and select 3-phase Phase 1 Master from the drop-down menu for inverter number 1, typically the leftmost inverter. However, physical order is irrelevant. Click Apply. You can see there are many selections in the multi-unit config menu. We typically only use the split phase and the 3-phase options. The others are just placeholders for future development. Next, navigate to the device identification section and select device number 1. Numbering is irrelevant, provided each XW Pro has a different device number, and then click Apply. Once you've programmed inverter number 1 as 3-phase L1 master, inverter number 2 as 3-phase L2 master, and inverter number 3 as 3-phase L3 master, with each having a different device number, it's time to set the system up for how you intend to use it. Any 3-phase source, whether grid or generator, must have a neutral for a 12208Y interconnection. With a 3-phase configuration, what you end up with is essentially 3 120-volt inverters that are 120 degrees out of phase with each other. This supplies 208 volts from line to line. The XW Pro 3-phase configuration requires an ABC rotation from the source. The XW Pro system will report an event code F70 if the rotation is reversed coming from the 3-phase AC source. In lieu of rewiring, it is possible to assign XW Pro number 2 as phase 3 and XW Pro number 3 as phase 2. XW Pro system may feed a Y primary Y secondary step-up transformer to power 277 480-volt loads. Since you shouldn't pass through more than 60 amps with a multi-unit system, utilizing an external transfer switch will allow the cell power to offset the grid demand and then switch the load to the output side of the inverter in a grid outage. Here's a normal operation. And here we see the loss of grid shifts all the load to the output side of the XW Pro system. If you can use an automatic transfer switch that has a dry relay contact to force transfer to the emergency side when the normal input is energized, in other words, using the grid on the emergency side, you can use the XW Pro aux port and an automotive relay to connect to the grid only when the batteries get low. This is a great solution for self-consumption. Many customers choose the ASCO transfer switch because they are cost-effective and reliable. The fact that they are a Schneider Electric division is an added value. The Series 185 is the most basic model, but lacks programmability for specialized applications. When switching may need to be prioritized in a manner that is more complex, the Series 300 provides greater flexibility and can use a dry relay contact for external control commands. Other high-end transfer switches are also available from ASCO, such as the Series 7000. These are able to alternate between two different generators. If this were a 6-inverter, 3-phase XW Pro system, the transfer relays for AC1 and AC2 will be protected. When the grid is present, the AC loads are served directly and demand is reduced by exporting PV and/or stored energy. Note that when the grid goes down, the ATS will switch to the backup position. The system will continue to run off the batteries until the grid comes back or the batteries get low. When a low battery condition occurs, the generator is started. Make sure the ATS for the generator can have a delay in case the generator needs to warm up before picking up a load. The generator will run until the batteries are charged to the desired level, which is programmable. Then the generator will be stopped. The system will continue to operate like this until the grid returns. Many customers choose to only partially charge the batteries with the generator. That way the PV has a chance to get the batteries charged fully. For a 40 kW 3-phase system, you can still use the power distribution jumpers. You just won't be using the sliding bypass interlock plate. When using an external ATS, that already provides bypass capability. Notice during the grid-connected operation, the 6 XW Pro units will be connected on the input side and offset demand with exported power. Those two 60-amp 3-pole breakers will be combined in one of the two power distribution panels with one of the power distribution bars. When the grid goes down, the external ATS shifts the load to the emergency side of the switch, which are being supplied by the output side of all 6 XW Pro units. The second power distribution panel will house the two additional QOU 360 breakers, which are combined with the second power distribution bar. The 12208 breaker kit, which is part number 865-1315-01, only ships with 3 QOU 360 breakers. So for this configuration, you will need to source one additional QOU 360 breaker separately. So the complete balance of systems for a 40 kW system will be 2 power distribution panels, part number 865-1014-01, or you can substitute 865-1015-01. You'll need 4 connection kits, which is part number 865-1020-01, and then one 12208 breaker kit. 6 XW Pros takes up a significant amount of bandwidth for a single Xanbus network. You'll easily have enough extra bandwidth to add a battery monitor, an AGS, and a system control panel. However, you will not be able to add several charge controllers to the same Xanbus network as the 6-inverter stack. For large DC-coupled systems such as this, use the secondary Xanbus network of Insight facility, which will aggregate the devices from both Xanbus networks to a single web page on Insight Local and Insight Cloud. Xanbus is an isolated network As such, there is no grounding in the RJ45 jack for shielded cable. This is why we provide grounded raceways in our balance of system components. Xanbus cables must not be routed in parallel with AC current carrying conductors. A single Xanbus network can accommodate 6 XW Pro units plus the battery monitor, AGS, and SCP when configured for 3-phase. Here's a sample system, DC coupled with arc fault rapid shutdown for rooftop solar. This may be used on-grid with a backup generator, or off-grid. Advantages of DC coupling include better efficiency when storing energy for use at a later time, and being able to monitor everything from a single platform. Here is a full sample ecosystem of Schneider Electric solar connected products. You can see in the top left, we have our Insight monitoring, which is our cloud and local area network monitoring, as well as a mobile app. Insight Home Insight Facility is the edge control device. Our connected products are Connect's battery monitor, AGS, of course, the XW Pro system, are all of our models of solar charge controllers, as well as the Disconnect RS. Here's a sample system that uses 6 XW Pro for a 40 kW system that uses an external AC contactor for 480 volt loads. Note a small transformer is needed for sensing. Here are 2 sample XW Pro 3-phase systems currently deployed in the field. The one on the left is AC coupled 20 kW 3-phase system. The one on the right is a 40 kW 3-phase system with 9 high voltage MPPT units for a DC coupled solution in Hawaii. And I want to thank you for joining today. This concludes the presentation, and we can take questions if time permits.
Thank you so much, Eric, for the wonderful presentation. We've got a couple questions here. Okay, this one is coming in from Matthew Huffman. For 3 inverters, 4 MPPT 100, AGS, and 9 Fortress batteries, do I need the Insight facility?
For 3 inverters and 3 charge controllers, you should be able to get away with the Insight Home. The cost differential is about $200. To be safe, you might want to just go with facility. I think that, I mean, the only consideration here is Xanbus, right? We don't have to worry about connected devices on RS-45 or CAN bus like integrated batteries. So with 3 inverters and 3 charge controllers, you should easily be able to fit those on a single Xanbus network. Good question.
Awesome. Okay, I'm going to give another couple minutes here. Let's see if we have any more questions coming in. It looks like we are good for now, but you can always feel free to send questions over if anything comes to mind after the presentation, or even in the post-webinar survey that will pop up when we close out here. There is a space for open comment, so if anything comes to mind after the webinar closes, always feel free to reach out, and we'll make sure to get your questions answered. So with that all said, it looks like we're good to close out. So thank you so much, Eric. Do you have any final comments or anything that you want to close out with?
Yeah, I would just like to say, Aaron, thank you so much for arranging this webinar. Schneider Electric is really excited about the XW Pro platform. We have a lot of functions and features that have been implemented that our customer base have been asking for many years now, and we've finally been able to implement those. Specifically UL 1741 SA. We didn't have the memory space to fit that into XW Plus, so we had to develop the XW Pro specifically for these new smart grid requirements that are coming to fruition here in the United States. So, you can expect the same robust surge capability and reliability out of the Pro, and I think that gives us a special advantage in the market. But again, thanks everybody for joining this webinar and allowing me to share with you today.
Awesome. Thank you so much, Eric. And make sure to everyone to fill out the post-webinar survey, and we'll be able to send you a copy of the presentation. Also, check out our website for more training opportunities and webinars, as well as upcoming events, now that we're able to kind of resume some normalcy little by little. And with all of that, just wanted to say have a great weekend, and thank you for continued business with AEE Solar. Everyone have a great weekend.
Thank you.
Bye, Eric. Thanks so much.
Bye-bye.
Bye.
Thank you.